All right, Algebra 2 students, let's finish up 3.4 and let's do our last problem for the videos. So I wanted to eliminate a variable again, and I think I'll just choose x again. Again, this is arbitrary, you don't have to choose x's, but when I see that they're all factors of 2 rather easily, I think it just makes sense to get rid of them, okay? And kind of as I look at this, if I took these first two up here, it wouldn't be bad to get rid of the x's. I just have to make them match. And to do that, I would need this one down here to have a 4. But I don't want it to just have a 4. I also want it to be opposite. So I'm just going to multiply the bottom one by a -4 there. So the top one, technically, I don't have to change at all. Right? Technically, I don't have to change that one at all. But I do have to change the bottom one. That's a -4x plus 16y plus 8z equals 8. Now, I have the same coefficient except for opposite signs on the x's. I can add those. That'll cancel those out. That'll give me 17y plus 13z equals -1. All right, that's not too bad. Next, I kind of need to rethink again, like, what do I want to do? I haven't used the third one. So no matter what, I got to use this third one. Okay? I have to use that third one. Now, it's a matter of a personal, opinion or personal preference here. When I see it, I still think the second one looks really easy to work with. If I made this a -2 and multiplied n times the top one there, I think it'd be rather easy. Again, though, the bottom one I don't have to change. I don't have to change the bottom one at all. So, I write that, but then the top one becomes -2x plus 8y plus 4z equals 4. And again, I'm allowed to just add these. I'll get rid of those x's. I'll get 11y plus 2z equals 25. All right, that's not too bad. Next, I have a 2x2. This right here, remember, is a 2x2 system. This is going back to 3.2 and 3.3. I just need to solve this using the same methods we've been using before. And I think I'll rewrite it down here just to make it a little easier to see. Z equals -1, and I have 11y plus 2z equals 25. Now again, you're using, most likely, most of you are going to use the elimination method here. Which, again, you can choose whichever variable you want to make match up. But I think I'm going to make the z's match in this case, which means I have to multiply this by a 13 and this by a 2. Now, they're both positive, so I need one of them to be negative, so I think I'll make this 2 negative. And now I'll just simply distribute like we've been doing. That's -34y minus 26z equals +2. And then again, if I distribute this 13, I would have 13 times 11. Now would be a great time to kind of take out a calculator. I want to make sure I get this right here. 13 times 11. Pretty sure though that's 143. That's a y. Plus 26z, because that's a positive and a positive, equals whatever 13 quarters would be, which is $3.25. And now I get to the pivotal point where I get to add. These will cancel, that's nice, that's 327 equals, well, let's see here, 143 minus 34, again, feel free to get a calculator here. I got 109, and that's y. And I need to divide by 109. And I'm pretty sure looking at that y would equal 3. Now this is great. Remember, that this is real important that I don't lose this answer that I just found. Okay? I got y equals 3. Now that I have one answer, I need to take this 3, right? That 3 right there, and I need to plug it back in. If we trace upward here, I need to plug it into one of these two 2x2s. Now, it doesn't matter which one I want. I see that this one, this second equation, I should say, is a little smaller, so maybe I'll plug it in right there. So that's 11 times the 3 plus 2 times. Now I've lost my big marker, but that's 2z equals 25. Now I just need to solve this. Well, this is 33 plus 2z equals 25. If I subtract, I get 2z equals a negative 8. Divided, I get z equals negative 4. Again, we do not want to lose this answer that we just found. I got z equals negative 4, and I got y equals 3. I need to take those two answers down all the way back up here to start, and I need to pick one of them to plug it into. Again, it does not matter which one you choose. I think just because this one's on the top, I think I'll plug it in there. Okay, I need to try to remember now what it was. I'm pretty sure y was equal to 3, and z was equal to, see, now I've already forgotten, negative 4. Is that right? Let's look down here, double check. Yeah, negative 4 and 3. Okay. Well, if I go to plug this thing in then, that is 4. I don't want this big marker. We better get a smaller one. That is a 4x plus 3 plus 5 times a negative 4 equals negative 9. And then I think I'll just kind of work vertically here. I know I'm going to write over what I have there. I think you'll be able to follow along decently easy. This would give me a negative 20, so I have 4x plus 3 minus 20 equals negative 9. Well, that's negative 17. If I add 17 across, I would have an 8, so I have 4x equals 8. I divide out and I get x equals 2. Remember, I wanted it as an ordered pair, so that's 2, 3, and negative 4. Okay, and there's my solution. Again, if we feel uneasy about it, we could check it by plugging it in to each one of the 3 original equations. That is the second example on your 3.4 video problems. You need to make sure that you have both problems completed before you come into class. And in class, we'll have some word problems and some more activity, kind of some active learning questions. And I'll look forward to seeing you in class.